For as long as we have stared into the universe, we have seen ghosts. From the ancients who quaked in fear at the augurs of comets and meteors, to the internet conspiracists seeing doomsday apparitions in Google's sky, the human race has traced its own illusions onto the night's black canvas. Astronomy is, after all, a purely visual science, and even aided by the most advanced technology, the human eye is as fallible as the mind it steers. Often, it is the technology itself that betrays us. Astronomy is a discipline that demands perfection, and even the most finely tuned instruments are not free from human error. But, very occasionally, what first appear to be ghosts can be the keys that open new landscapes. Case in point, William Herschel, a frequent visitor to my channel and, at this point, verging on a personal idol. In 1793, 12 years after his epochal discovery of Uranus, he submitted a paper claiming that he observed a faint ring around his planet. Quote, "The ring is short, not like that of Saturn, and this may account for the great difficulty of verifying it. It is discernible that the two ansae, or handles, seem of a color a little inclined to the red." But, try as they might, the other great astronomers of Herschel's day could not replicate his finding, and by 1793 he declared it a phantom, possibly due to an imperfection in his telescope. In 1797 he wrote, quote, "The supposition of the rings should be given up as ill-founded." Unquote. And yet, this story of optical oddment was not over. It would have a sting in its tail, one that would not reveal itself for over 200 years, and to which I shall return in due course. Another eye to spot a solar spirit belonged to William Lassell, hero of the last episode, who, when John Herschel, son of William, wrote his frenzied letter to him demanding that, having lost the chance to claim the planet Neptune for Britain, Lassell, quote, "find satellites with all possible expedition!" responded that he would search for rings as well as moons. Why would Lassell mention rings? Well, evidence suggests he'd already glimpsed a ring through his telescope. On the 2nd of October 1846, 10 days before he received Herschel's letter, Lassell recorded that he observed a faint ring around Neptune. On November 10th, Lassell invited other astronomers to his home to see if they could repeat his observation, and all of them confirmed it. Lassell then notified James Challis, a man widely, if unfairly, blamed for losing Britain Neptune, who also reported that yes, he could see a faint ring around the planet. That appeared to clinch it. If more than one observatory could see it, then it could not be due to either flaws in the telescope or human error. But then, in 1852, Lassell upgraded his telescope and moved it to Malta, where the better viewing conditions would ensure that he could clinch his discovery. And at first, he did. Aided by his newly rejuvenated telescope and clear Mediterranean skies, Lassell thought he could see his ring. And then he saw it jump. And jump again. And again. Like everyone else on the planet with the possible exception of William Herschel, Lassell had never observed a planetary ring other than Saturn's. But he was fairly certain that, as a rule, it could be assumed that they don't jump. The ring, he concluded, had to be the result of a technical fault in his telescope. But if that was the case, how had so many others seen it? To this day, no one knows. Perhaps it was due to bad seeing conditions. Neptune would have been on the horizon at the time. Or it might have just been a case of collective wishful thinking. People wanted to see it, so they did. It would not be the last time such a thing would happen in astronomy. And now, we must jump forward in time over 100 years, to 1973. With Mariner 9 having just completed its year-long orbit of Mars, and the Voyager is only a few years away, it was very much the point at which the discipline of planetary science, begun by Galileo in 1610, would see the space probe replace the telescope as its most iconic instrument. And, at the Royal Greenwich Observatory in London, an astronomer named Gordon Taylor sought the chance to do some old-school planetary astronomy. Specifically, he wanted to view Uranus during an occultation. An occultation, more specifically a planetary occultation, is a somewhat rare event in which a planet or planetary object passes in front of a star. The timing and manner in which the star dims as the object blocks its light can often reveal aspects of such objects invisible to telescopes. For instance, by taking a spectrum of a star's light as a planet passes in front of it, you can read the elements in the planet's atmosphere. Pluto's atmosphere was discovered during an occultation. By far the simplest use of occultations is to obtain accurate measurements for objects' diameters. By precisely measuring the time a planet dims the light from the background star, you can accurately determine its angular diameter, or how much of the sky it appears to take up from your position. And, if you happen to know the planet's distance, a simple bit of math will convert the angular diameter to actual diameter. Taylor felt that Uranus's diameter could be, tightened, so he scoured the future to see when the planet would next occult a star. The next would be in 1977. And to make things worse, once 1977 arrived, there was only one narrow band of the Earth from which the occultation would be complete, over the southern Indian Ocean. Observing a total occultation required an observational precision equivalent to a 7,000th of a degree. Thankfully, we had certain things at our disposal by then that we didn't have before, namely the Kuiper Airborne Observatory, basically a Lockheed starlifter with a 90-centimeter telescope sticking out the side. And on March 10, 1977, at 2050 local time, astronomers Jim Elliott of MIT and Robert Dunham of Lowell Observatory settled in to watch the show. It would have a twist that no one saw coming. As the team prepared to take their measurements, the star, an unassuming nameless star in the Smithsonian Observatory catalog, did something remarkable. It winked, and then it winked again, and again, 5 times. Other observatories positioned slightly off the main path corroborated the team's result. There was something orbiting Uranus. Of course, that something had to be satellites. What else could it be? Rings don't behave like that. At least, Saturn's didn't, and Saturn's were the only rings anyone had ever known. But Elliot had suspicions. After returning home, he and his wife Elaine spread the results over their living room floor, and discovered that the 5 occultation events were exactly repeated on the other side of the planet. For satellites to align themselves so perfectly for that one moment was essentially impossible. Their discovery could only be rings. It was the first major addition to our solar system's geography since Pluto was discovered 50 years earlier. Later, they found 4 new rings, bringing the total to 9. It may seem historically strange that Uranus's rings were the first to be discovered in our solar system, since Galileo first studied Saturn over 350 years earlier. But in fact, it makes sense. Uranus's sideways orientation means that its rings orbit it like a target, meaning they could be captured by an occultation. Had Uranus orbited the right way up, then they would have been a paper-thin line, likely invisible until the Voyagers, launched later that same year, finally arrived. The Voyagers would, just 2 years later, discover the solar system's 3rd ring system, a wisp of dust around Jupiter, as fine as cigarette smoke. And 5 years after that, in 1984, astronomers got the first hint of a ring around Neptune. Within a decade, rings went from being the exception for giant planets to the rule. Precisely how Uranus's rings could maintain their rigid paths remained a puzzle. In 1979, astronomers Peter Goldreich and Scott Tremaine, the man who would one day name the Kuiper belt, concluded that interparticle collisions, radiation drag, and other effects would smear out any such confined rings, just as had happened around Saturn, in less than 100 million years. Later researchers revised the number down to less than 1 million years. The two predicted that the gravity of tiny satellites could shepherd the particles of the rings into their narrow orbits, an idea unexpectedly confirmed just 1 year later when the Voyagers arrived at Saturn and found a number of such satellites shaping the structure of the planet's vast ring system. When Voyager 2 finally arrived at Uranus in 1986, it found a ring system about as far from the grand glittering arc of Saturn as night is from day. Farther, in fact. Saturn's rings are almost pure, searing ice. Uranus's rings are among the darkest natural structures ever discovered. Their albedo is just 1.6%. For comparison, fresh asphalt has an albedo of 5%. The rings display almost no spectral features, meaning that no one knows precisely what they're made of. But given that Uranus's moons are made of a mixture of ice and carbonaceous material, it seems likely that the rings are too. though with far less ice and far more carbon. Voyager 2 also found 2 new rings, bringing the total to 11. The rings were entirely self-contained and strikingly narrow. The widest, the Epsilon Ring, was only 100 kilometers wide. Flashing a camera 100 times a second as the rings passed in front of the variable star Algol, Voyager was able to determine the size of the particles of which they were composed. Surprisingly, despite their solid appearance, the rings were found to comprise a swarm of objects ranging from 1 to 10 centimeters in diameter, roughly the size of rocks, although the rings were also essentially invisible in direct sunlight, meaning they were almost completely devoid of dust, which would have sparkled in the light. The lack of smaller particles was put down to drag from hydrogen in Uranus's upper atmosphere, which extended into the rings. As expected, the rings had sharp, well-defined edges, and Voyager 2 discovered a possible reason why. A swarm of 11 new moons, all closer to Uranus than Miranda, which flitted between Uranus's rings in a manner strikingly similar to the shepherd moons of Saturn. The first moon found by Voyager 2 was actually photographed months before closest approach, and in deference to the original idea of naming Uranus's moons after fairies from English literature, was named Puck, after a mischievous imp in Shakespeare's A Midsummer Night's Dream. Like everything else orbiting Uranus, Puck is dark, but it is still far lighter than the rings. In light of the destruction of the Space Shuttle Challenger, which occurred just 4 days after Voyager's closest approach to Uranus, a petition arose that the new moons be named in honor of the 7 astronauts who lost their lives. But it was decided that, in keeping with other astronauts who had died in the line of duty, their names would be given to craters on the far side of the moon, and the team would follow the more inclusive example of Gerard Kuiper and just grant every moon a name from Shakespeare, fairies or not. Today, the moons of Uranus resemble the cast of a Renaissance fair. But, frustratingly, none of them appear to be doing their job. Uranus had loads of confined rings, and loads of little moons, but of the expected shepherd moons, there were few to be seen. Only 2 of the observed moons were massive enough to have confined any of the rings, and they orbited the Epsilon Ring, the largest and brightest ring, in a similar manner to the shepherds of Saturn's F ring. Named after 2 of Shakespeare's feistiest tragic heroines, Cordelia and Ophelia were caught in a 13 to 14 and 24 to 25 resonance with the Epsilon Ring's inner edge, and a 24 to 25 and 47 to 49 resonance with the ring's outer edge, respectively. These form what is called a Lindblad resonance, when the gravity of a satellite forces ring material into non-circular orbits. This explains why the Epsilon Ring has the least circular orbit of any ring in the solar system. And it is this ring that one astronomer at least believes may be the ultimate vindication for William Herschel. Remember how in 1797 he believed he saw a ring but was forced to recant? Well, in 2007, Dr. Stuart Eaves of Surrey Satellite Technology Limited suggested that the ring Herschel believed he saw may have been the Epsilon Ring. Herschel's description of its size relative to its planet and its orientation are close enough to the Epsilon Ring to suggest he may have seen it, and since we know that the rings of Saturn can vary in albedo with time, the Epsilon Ring might have been brighter in Herschel's day. Unsurprisingly, this idea has not caught on, because it's fairly unlikely that Herschel, who, remember, himself ultimately rejected his ring observations, could have seen a ring that no other astronomer spotted in 200 years. In 2003 and 2005, the Hubble Space Telescope discovered 2 faint outer rings, really ring-shaped clouds, in the edges of the Uranian system. The outermost ring was blue in color, and likely composed entirely of water ice stripped from the small moon Mab that orbits within it. But the inner ring was, as Herschel had said, slightly inclined to the red. Did Herschel outsee the Hubble telescope? Well, no. But it does highlight what a powerful role coincidence has always played in solar system discovery. Voyager 2 left the Uranian system with many mysteries still unsolved. Where was the swarm of shepherd moons required to keep the rings confined to their narrow paths? What exactly are the rings made of? But perhaps most perplexingly, where did they come from? The orbits of Cordelia and Ophelia suggest that they couldn't have been maintaining the Epsilon Ring for longer than 600 million years. It has been speculated, just as it has for Saturn, that the rings formed from the shattering of a smallish moon. Puck, the most massive of Uranus's smaller moons, would take 1 billion years or so to be destroyed by an impact. So it's possible the rings could have formed multiple times through the destruction of other moons the size of Puck. Several of Uranus's smaller moons, particularly Cressida, appear to be on collision courses with other moons within the system, which could result in the formation of new rings. Cressida, in particular, could collide with the moon Desdemona within the next 1,000,000 years, or perhaps the moon Juliet within the next 100 million years. The moons Cupid and Belinda are also expected to collide with one another in future, though for them the time frame is less certain. While some are willing to grant William Herschel the posthumous glory of having discovered a ring, precisely no one is willing to extend that grace to William Lassell. Attempts to find a ring around Neptune over the centuries were akin to extracting water from a stone, and Neptune isn't even sideways. By the 1980s, observations from occultations had shown that something was orbiting Neptune, but no one could be certain as to what it was. A satellite? A cloud of debris? Or something else entirely? This ghost was proving hard to catch. And then, on the 22nd of July, 1984, astronomer W.B. Hubbard and his team caught a flash of translucent fog through the light of an occulted star. It was ragged and uneven, and only either on one side of the planet or the other, rather than on both sides, as would be expected for a ring. In his paper, Hubbard concluded that, rather than a continuous ring, Neptune was instead orbited by a broken chain of material he dubbed arcs. This may have fit the data, but it unleashed a whole host of its own problems. Harold Ritsema, an astronomer who had led the search for Neptune's rings, declared that, quote, "I am willing to accept part of a ring, but that creates real problems, because I don't understand how you get parts of rings." When Voyager 2 arrived at Neptune 5 years later, one of its primary goals was to finally sort out how Neptune could have parts of a ring. And it succeeded. The reason Neptune had parts of a ring was because, well, it didn't. The outermost ring of Neptune was in fact continuous, but possessed regions in which the material was bunched up, which the NASA team, not to give up on a good name, still refer to as arcs. Initially, the team saw only 3 arcs, and, in keeping with the nationality of Neptune's discoverer, Airborne Leverrier, named them Liberté, Égalité, and Fraternité, after the model of the First French Republic. Later they found another arc, and, needing a 4th virtue, chose Courage. Then they found a 5th arc and gave up, naming it simply Égalité 2. The outermost ring is the only one of Neptune's rings visible from Earth, but Voyager 2 found 4 more, which were named after Neptune's discoverers: Adams, Arago, Lassell, Leverrier, and Gala. And if you're wondering how one planet can have 5 discoverers, I'm afraid that's just too crazy a story to sum up here. Please see the linked video above for an explanation. Gala and Lassell are broad but faint, ranging between 2,000 and 5,000 kilometers in width, while the others are comparatively as narrow as wire, less than 100 kilometers in width. They are dark, almost as dark as the rings of Uranus, and likely for the same reason. Observations in backscattered light suggest the rings are primarily composed of micrometer-sized dust, from 20% to as much as 70%, which makes them similar to the rings of Jupiter or Saturn's G-ring, though the dust might also be home to rocks of up to 20 kilometers in diameter, as yet unseen. Dust would eventually become a worry for Voyager. As it approached within 86,000 kilometers of Neptune, the number of collisions hit 300 per second. Dust would not survive long in the tenuous upper atmosphere of Neptune. For it to survive, it must be replenished. Exactly what is doing the replenishing is not known, but it could be any number of large bodies. Why Neptune's rings should be so tenuous is not clear. The Neptunian system actually contains more mass within its ring region than Uranus, so it's not for lack of material. As per usual with rings, the arcs in the Adams ring could not possibly have survived this long unless something was corralling them. The clumps, if left alone, would merge with the ring in less than 5 years. In this case, the culprit turned out to be a tiny moon the team named Galatea, which is in a frankly ludicrous 42 to 43 resonance with the Adams ring. Galatea also has its own faint ringlet, made from particles escaped from its surface. Problem is, a 42 to 43 resonance should produce 42 8-degree nodes throughout the entirety of the ring, in which you would expect to find additional arcs. But the arcs seen on the Adams ring only ranged across 33 degrees of its circumference. So where were the rest? Also, the rings were not in the exact position predicted by the resonance. Some scientists have conceived an as-yet unseen extra moon to account for this. This and many other questions, such as how old the rings are, how the other rings are confined, and precisely why the rings are as flimsy as they are, will have to wait until the machine god of NASA deems us worthy of a Neptune orbiter. And that's it, I'm afraid, guys. Not as hearty a meal as I usually offer, I know, but there really isn't that much information on this topic. My next topic, though, will have oodles of information to work with. Millennia's worth, in fact. So please, stay tuned for that. See you next week, guys, and don't forget to like, comment, and subscribe, because apparently the algorithm only really works if you do that. And as always, stay curious, fellow seekers.